My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 571. In this lecture, we will try to understand batch SGD with momentum. So, in the previous lecture, we saw that the SGD updates are noisy as compared to GD updates or gradient descent based updates. Basically, the derivatives are gradients that we compute using SGD are noisy because they are approximations to the gradient descent updates. We said, can we somehow denoise this data? We said, can we somehow denoise this data? Let's understand a very simple concept of denoise. Imagine if you give me a bunch of numbers. Let me say, imagine if you give me a bunch of numbers, let's say A1, A2, A3, A4, A5, A6, so on, isn't it? Let's say this value A1 at time t equal to 1 and A2 at time t equal to 2, so on, A6 at time t equal to 6. One simple way of denoising is to take averages, isn't it? So at time t equal to 1, I have only one value which is A1. Yes, therefore, let me write V1 equal to A1. At time t equal to 2, I have two values. I have already seen A1. Now I am seeing A2. So what if I write equation like this? Let me say where V2 equal to gamma V1 plus A2. What is this gamma? Gamma lies between 0 and 1. If gamma equal to 1, what happens? My V2 equal to A1 plus A2. V2 equal to V1 plus A2, but V1 equal to what is my V1? V1 equal to A1. Just check this one. What is my what we are doing here? This I am assuming gamma equal to 1. Here I am substituting gamma equal to 1. Therefore 1 into V1 plus A2. But what is V1? V1 is nothing but A1. Is it not? Yes. What happens if my gamma equal to 0? If I substitute gamma equal to 0, what happens? This is 0 into V1 plus A2. That is V2 equal to A2. What happens if my gamma equal to 0.5? Then my V2 becomes, just see, V2 becomes gamma equal 0.5. Gamma means 0.5 into V1 plus A2. 0.5 V1. What is my V1? My V1 is nothing but A1. Just see, V1 is A1 plus A2, isn't it? Therefore, my V2 equal to 0.5 A1 plus A2. So, what I am saying here is, you can think of this like a weighted sum where you are giving more weights of 1 to most recent point that you have seen, isn't it? Less weight to the point that we have seen in the past. Just see which one is most recent point here. A2 is most recent point, isn't it? Just check it out. This here A2 is most recent point. What is its weight? Its weight is 1, isn't it? Previous point is A1, its weight is 0.5. What does it mean? What is the meaning of this? What's happening here? You are giving more weight to the most recent point that you have seen, and less weight to the point that we have seen in the past. So let's just extend this. V1 equal to A1, V2 equal to gamma V1 plus A2, isn't it? What is my V3? V3 is, it's simple. My V3 is This is V3, therefore I will get V2 here plus A3. Yes, V3 equal to gamma into what is my V2? My V2 is gamma V1 plus A2. Just I am substituting, isn't it? As we are saying, what is your gamma? It lies between 0 and 1. Remember, gamma lies between 0 and 1. Isn't it? This is something, this gamma is something less than 1, isn't it? As it lies between 0 and 1, let's say gamma equal 0.5. Then what about V3? 0.25 A1 plus 0.5 A2 plus 1 into A3, isn't it? What happens? I have seen a value A3 and hence I am giving more weight, isn't it? More weight to A3. I am giving more weight to A3 and I am giving lesser weight to the previous points that I have seen. I have seen A2 at time t equal to 2. I have seen that point A1 at time t equal to 1. So the most recent point that I have seen here is giving more weightage. The next recent point I am giving lesser weight. Next point I am giving still lesser weight, isn't it? Now what happens? V4 can be written as V4 is 0.125 A1 plus 0.25 A2 plus 0.5 A3 plus A4. So I am getting more weight for A4, less weight to A3, still lesser to A2, still less to A1. So if you employ this function, let me write this function V1 equal to what is this? V1 equal to A1, VT equal to gamma into Vt minus 1 plus At. This is called a recursive equation in computer science, or recurrence relation, I can say. A V is a variable that changes over time. V is a variable at time t. Vt minus 1, you have the value at previous time, isn't it? You are expressing tth term in its previous term. That's why it is called recurrence relation or recurrence equations. As you are getting more and more data with time, by performing this, you are sort of performing like average, like denoising, isn't it? By performing this particular equation 1, V at any time can be thought of. What is my V? V at any time can be thought of denoising, isn't it? What is my Vt? I can say it is basically useful for denoising. It is some sort of average, isn't it? Denoised, I can say denoised estimate, where you are giving most weightage to most recent point and you are giving less weightage to the previous data point. In this lecture, I provided a reference link from Towards Data Science. Very nice example. I will provide this particular link in comment section and as well as in video description. Very nice example. It understand, so you can understand better. Let me explain this. You have some data here. Each of these are data points. Each of these blue points, I can say each of these blue points are data points, isn't it? Each of these blue points are data points. Remember, the data is very noisy, isn't it? The data is very noisy. The original function looks like this red line. The red line I am highlighting, this red line here is original function. This original function is something like this is like a derivative of L with respect to W using gradient descent algorithm, which is the original. The blue ones are the noisy data. I can say the blue ones are noisy data. You can think of blue ones as derivatives that we get with the help of what is that derivatives with the help of using stochastic gradient descent. So the blue ones are very noisy, isn't it? That is dou L by dou W with the stochastic gradient. So one way to kill up this noise is something called exponentially weighted averages, which is exactly what we saw right now, isn't it? Because if you look at it, it is called exponentially weighted average, because if you think about it, V at any time t is Vt equal to 1 into At plus gamma into At minus 1 plus gamma square into At minus 2 plus so on and so forth. Isn't it? We are giving weight 1 to most recent point. Which one is most recent point here? At, whose weight is 1. Weight of gamma to the second most recent point, gamma square, to the third recent point, gamma cube, to the fourth recent point, gamma 4, so on. Exponentially you are reducing the weights because your gamma lies between 0 and 1. 1 is greater than or equal gamma, gamma is greater than or equal gamma square, 1 is greater than or equal gamma, gamma is greater than gamma square is greater than gamma cube, which is greater than gamma power 4, so on. You are giving weights in such a way that, what is this? Gamma power 0, gamma power 1, gamma square, gamma cube. This 1 can be treated as gamma power 0. So this is called exponentially weighted averages. In this case, I can say it is exponentially weighted sum. Just see this one. It says exponentially weighted averages. I request all of you to go through this blog once so that I will continue my discussion on batch SGD with momentum in my next lecture, that is in lecture number 572 also. Thank you very much.